guys? It's Kayla.
And Jim.
And welcome back to another Meteorology Monday. What are we reacting to today?
We had a lot of viewers recommend us to watch Stonados. So we are going to do a Met Reacts. Came out in 2013, and we did post on Instagram our initial thoughts when we started the movie, and some of you may have seen that and gotten a good laugh out of it.
It's a fantastic quote by Dad.
But
see it.
Before we get started,
make sure you give this video a thumbs up and subscribe down below so you never miss another Meteorology Monday. While you're at it, go ahead and follow us over on Instagram so you can see the stories we post while we're reacting to these videos, along with Dad's top quotes of 2022.
That's right, and there'll be many more to come, we promise you.
Also, while you're at it, if you haven't heard, we have something called the School of Weather, which is live now. It is online courses, 5 topics, the basics of meteorology. Check us over on Teachery. We'll leave the link down below if you're interested in learning about foundation level of meteorology.
All right, so let's get into it. Stonados. So their setting is Boston, Massachusetts, the Boston area. The weather is kind of going crazy.
It's kind of, it's off its rocker.
It was set up in the 2013, like we said, so the early 2010s when a lot of things were coming out. 2012 and other movies that were a lot of climate change focused, centric focused movies. Of course, they didn't really hammer a lot of climate change with this. I was surprised. I thought they were going to have a lot more, but they didn't.
They had different explanations, which we'll get into. So yeah, important to note, this is in the climate change era of weather movies, but this one does not focus on climate change. It focuses on something else.
It actually focuses on Stonados.
Yes, let's dive in. It's a little windy.
So right off the jump, we got ourselves a water spout forming.
Sir, it's awesome!
It is awesome.
Sir, recently! It's fine! The storm will only last a minute or 2!
Oh, okay.
It's too strong!
Whoa, he just threw his hat.
Does that fall into the category of losing the hat?
We'll consider it.
It's in the same spot.
Oh!
All of a sudden she's...
What the heck?
He's not lifted off the ground, but she is. And then Plymouth Rock right behind her.
And that's it.
Okay, so that was the opening scene. Let's state, we know that this is CGI era stuff. We get that. We know that this is not real. They're all making it happen.
We are aware that this is a movie and it is a fake event. Yes. It is CGI. Yes.
Yes.
We are also aware that while you are making a movie, one must have some elements of realism and, the stones crumbling around this dude while his hair's not really blowing, and then she gets sucked into a tornado.
It's
probably does not go on the scale of realistic.
And then her just flipping and then just staying still and just getting sucked in. Let's focus on the meteorology, shall we? So let's say, for example, that we do have technically it's really a water spout that has formed into, it's kind of morphing into a tornado over water. Do you want to give it a little explanation?
So there's actually a difference between a water spout and a tornado over water. If you haven't seen, we do have a video on the differences between water spouts, land spouts, tornadoes, and tornadoes over water. A little brief definition there is tornadoes form from the cloud down, water spouts form from the water up. So it's kind of like a swirl of wind that's not connected to a supercell, whereas tornadoes are connected to storm systems. This one, it kind of looked like it was starting to form as a water spout because you had the little bit on the bottom. We didn't see a condensation funnel, but then it was as strong as a tornado. Usually water spouts are EF0s, EF1s, very, very weak because they're not connected to storm systems. So for this one to be like grabbing people off the mainland,
far away,
not very water spout of it.
You're right.
But meteorologically, okay.
All right, so let's go with it. Let's say it morphed from a water spout to a tornado over water. So it got strong. Was it at that distance strong enough to pull her like that and then just pulled her straight into the funnel versus kind of following the wind flow
It wasn't
around.
even.
It looked like the wind was just going straight into the funnel, which typically is not the case. As you could see, they had the swirl going around the funnel, but she just went straight in. So that wasn't consistent. The CGI, you know, they
kind of looked like it was the apple twister emoji.
Let's just...
We'll just keep going.
We'll just keep going. Hopefully it gets better.
Barometric pressure is low and dropping fast.
Let's pause it here for a second. So that is the reading off of a barometer showing the pressure of the atmosphere. Tornadoes are low pressure systems, and standard atmospheric pressure is 1013.25 millibars, which we can see on the corner of the screen here. It says normal is 1013 millibars. I don't know where his barometer is though in his flip phone to be getting this information, and I don't know what this image is because that's not from a barometer.
Yeah, I'm not familiar with this at all, unless it's some sort of app. Let's just go with
We'll
it's
go
an
with
app on
that.
the phone, and it's been tracking their barometric pressure over time, and he's opened it up, and there it is. It's got a gradient of pressure, and it looks like there's numbers on the left side that indicate pressure in millibars. There's nothing that I can tell on the x-axis of what it's measuring against, so I don't know. And then we have contour lines.
We can put this in the bucket of image does not match description in dialogue.
They tried.
But I see that they tried. They've got the standard atmospheric pressure and they have the word barometer. So, you know, we'll just, you know, there we go. Okay. And here we go with a weather map. We have wind barbs on the left side. We have low pressures. We have some sort of scribbles on the bottom. It looks very scientific. I'm not sure why there's 7 different low pressure systems on this map, but it's a map of Boston. It's got some pressure contours and it's got some wind speed. I'm not sure what the wind barbs are though.
Not sure, and there looks like contour lines, but there's no values associated with them, so how do we know what L is? Are they all the same, or is one stronger than another? Northeast of Boston, where you got one low and then another low, you've got winds that would be kind of, it's not meteorologically accurate.
But if you don't have the numbers, what are they reading off of this? What information are they gathering from this? Nice try, better than most, not quite there. Vector differential applied. It is not even. It's backing.
Veering or backing.
It's backing with height and not veering with height.
We just noticed. Let's talk about the wind barbs over on the left side. So it looks like it's a winds with height, and as we've discussed in other
case
reacts
studies
and case studies and everything else, so you kind of want veering with height. You want the wind to be out of, in the northern hemisphere, out of the east, southeast, southeast, south portion, and at the surface, and then as you go up, it veers or turns more to the southwest and then a westerly direction as you go up in height to get that spin. So when we look at this, it looks like starting at the surface and going up to about 12,000 feet, but the winds come out of the south and then they come straight out of the north, and then they wind up backing instead of veering. So they go northerly, and then as you go up, it goes back to the west, which is not conducive for a typical storm structure that supports tornadoes or tornadoes over water.
This is in fact the opposite of what you want to see. At least they have wind barbs on here.
Yes.
But so far, I think this weather map is taking more L's than they have listed. Let's see some more.
Whoa, what? The local barometric pressure's dropped 27.12 inches at 885 millibars in the last few minutes.
Let's go back to what he just said. He speaks so fast that it's hard to tell what he's saying, but I think he just said that local barometric pressure has dropped 27.12 inches of mercury to now be 885 millibars, which doesn't make sense. So let's go with option number 2, which is that barometric pressure in this location is now 27.12.
It dropped 2.
Yeah.
It didn't drop that much, it dropped 2.
It dropped to 27.12 inches of mercury, or 885 or 889 millibars. Which, let's just start with that. 27.12 inches of mercury is roughly, I believe, 913 millibars, not 885. However, one of the strongest hurricanes ever recorded was 887? 888?
888 was Hurricane Gilbert. And that was, winds gusting 200 miles an hour.
And that's a hurricane.
Wilma was 882 in 2005.
He's saying that the local barometric pressure just dropped to a Cat 5 hurricane and over 200-mile-per-hour winds, yet it is a clear sunny day with a waterspout off the coast. Oh, and let's also point out real quick, guy on the left is the meteorologist. Guy with the phone and the fancy barometer app is a volcanologist. Don't know why they gave him the barometer. Next clip.
The waterspout's decayed.
Now he calls it a waterspout.
I've never heard of one lasting that long before.
So the volcanologist here just said it decayed. Like, thank you, Captain Obvious, but he's the one, that says it. And then the meteorologist says, finally, I've never heard of one lasting that long. What kind of meteorologist are you? The thing lasted 4.5 minutes.
I mean, it's almost like the volcanologist has more meteorology experience and knowledge than the actual meteorologist. That's how they wrote this movie. Maybe the volcanologist's undergraduate degree is in meteorology and his graduate and PhD were in volcanology. Let's go with that.
But that's what we have to go with. Ignore the title.
I haven't even finished reading it yet.
I labeled the clips.
I'm out. So let's just say we need to see this next clip. Well, I dry my eyes.
Check this out. When the seamount chain of underwater volcanoes erupted 2 years ago, a massive amount of sulfur dioxide was released.
Yeah, it caused the temperatures in the outer atmosphere to cool, creating a minefield of extreme weather pockets.
Theoretically, we could be hit by a series of F5 tornadoes with winds up to 300 miles per hour.
Can you figure this out how?
Well, I ran a series of tests, and this looks pretty real.
We need to show the step away.
So, in summary, the meteorologist is now doing volcano stuff, while the volcanologist is doing weather stuff.
Maybe the meteorologist's undergraduate degree is in volcanology.
Stop! Don't make it better! Don't try! Let's just speak to the meteorology here. No. Any volcanologists chime in the comments?
Yes, we want to hear from you guys.
Sulfur dioxide to the mesosphere?
Let's start with, okay, from 2 years ago there was an eruption, okay. Cooling, temperatures regionally, okay, we're on board with that. Emitting things into the air,
yes.
Right with you. But then it goes past the stratosphere and into the mesosphere and just kind of hangs out there.
For 2 years.
With these big boulders suspended. I mean, if you had stuff from outer space and it gets into our gravitational field, it starts falling through.
Oh, that's another thing.
It continues to fall. It doesn't.
Gravity.
It doesn't stay. So
right.
How these were suspended.
Maybe it has to do with like the buoyancy of sulfur dioxide compared to oxygen, but there's not really much oxygen because the air is thinner, but we're higher in the atmosphere. No idea.
But that leads me to another. Well, we'll get there.
We'll get there.
Let's just.
We're going to talk about ozone layers here in a second. But first, let's go to the FOA, which does not stand for what you might think it stands for. Federal Oceanic Agency. NOAA's non-existent.
There have been over 150 tornadoes recorded in Massachusetts over the last 60 years. But, Mr. Carlton, there's no evidence that today's harbor incidents were nothing more than that. Isolated incidents.
Isolated.
So the equivalent of NOAA, National Oceanic and Atmospheric Administration, the high-up government weather people, are discrediting these two degreed meteorologist, volcanologist people who have witnessed two weird tornadoes, and they're saying this is normal in Boston and an isolated incident.
And they've got no word about the first one dropping stones and then this one dropping stones. They've got no word.
They have no idea.
Normal incident, nothing to see.
Nothing. Incorrect.
you have stones falling out of a tornado. No warnings, nothing. It just isn't consistent.
If these two crackpots are getting, updates on their laptop and flip phone about low pressure and warnings and winds and all this stuff, how does the FOA know people not know about this?
Oh, that also brings up another thing. So not to mention that this was written in 2013, so it's many years after we stopped using the F scale. We're using the EF scale, but they keep referencing the F scale. So unless there's a reference back to something before 2007 that this is situated in, they should be referring to the EF scale instead of the F scale.
Look at these clouds. They look so promising.
Now that's realistic.
That's real.
Right
Look
there.
at that. There's little water spouts everywhere.
And
that
then we
not...
go to this.
Nope.
Now it's following the meso.
Okay, there was lightning there. Now while this is happening, he's sleeping. And the simulation has run its course. We're about to see what it is.
Right, because it was going to take 6 hours for it to run.
Right?
So
6 hours later.
he kicked it off, fell asleep,
Here we
woke
go.
up to the final product. So massive storms erupting and moving in over the New England area.
Now it says he's running a tornado simulation, so I'm not sure what it's supposed to be, but this looks like a radar. It also doesn't look like a radar.
A lot of these images, we just see the details are out of focus, so we really can't tell what specifically it is. We can only take a best guess, and based on their conversations and stuff, kind of interpret what it is. But it does look like it's a simulation of some sort of storm growth, and it looks like a really big storm with a big core is about to move into southern New England and up toward the Boston area. Let's see where it goes from here.
Okay. Now, these stones explode.
So it's not just bad that they're falling out of the sky, then they take time to explode.
I don't think I know what we're dealing with here.
And your tornado simulations indicated there's going to be more of these coming.
That's right. The simulation also indicates that the storm's path is coming right up the river.
Storm simulation showed a giant red blob over most of the Northeast.
And why is the volcanologist writing a tornado simulator? And he did it overnight? Why isn't the meteorologist? Didn't he have a model that was doing something?
At the
No,
beginning?
it was doing
did-
volcanology because it was
his model
spewing
was-
stuff
yep.
into the mesosphere.
Yep.
A little sideways here.
So we got a plan this time?
Ah! He has a kestrel!
The megaphone.
Why doesn't the meteorologist have the kestrel?
Temperatures dropped 2 degrees and wind speeds just doubled.
The wind speed seems to be about 3.5 miles per hour. I'm not sure what the significance is of it doubling.
Well, the temperature dropped 2 degrees.
Maybe the sun went behind the cloud. I don't know.
So the atmosphere is balancing out the 2-degree drop with an increase of 3.5 miles an hour.
Good job. The atmosphere is working.
Clearing this area is not going to be easy. There's a whole layer of politics we need to work through.
We have to get those people out of here, Maddie.
When do you predict this storm is going to hit?
Guys?
Now.
Take a look at the image. And
I think the clouds are cutting through the middle of the buildings. Something does not look correct here.
Storm Structure 101, can you point out the obvious for us down in the comments below? The tornado looks to be about like 20 feet off the surface of the water, with the cloud deck being about 20 feet off the water, and it's only there.
It looks like the main storm is out over the city.
There's pockets of calm water right there to the left.
There's no waves on the water.
No waves. Oh look, and we have a random stone that just popped out of it's pulling up stones out of the riverbed.
I thought the stones were coming from the mesosphere. What are they doing?
If you see this, you'll see the stones being pulled up from the water, yet they're talking about them falling from the mesosphere. Oh, it just gets worse.
Here we go. Back to the FOA.
Whatever you do, stay in your homes and do not go near the water.
Those two are right. It looks to have been an F2 or F3 water spout. Call NWS and issue a marine warning immediately.
Not a tornado warning?
Not yet. So far, these are all tied to water, so let's not get ahead of ourselves. Just a storm advisory and tornado watch.
So technically, it would be a special marine warning because it's out over the water.
Let's point out the biggest problem with this. Why are they telling NWS to do anything? NWS, this is their job. This is what they do. They're not just sitting there waiting for orders. The NWS is the one that comes up with what to issue, when to issue, and where to issue.
Yeah.
They don't wait for somebody to tell them that.
It's kind of like they divided storms on the land and storms on the water. And it's almost like the National Weather Service has no authority to do anything with any storms over the water, or maybe they might not even be aware of what's out over the water. Once it crosses that threshold and gets out over the water, the FOA takes over, and that's not how it works.
That's not how
so
it works.
That's incorrect there
That's
off
incorrect.
the jump. All right, so
I think I could do this with just the apple emoji of a tornado and perhaps some gray clouds in Photoshop.
the meso's just rolling in like stationary, and the tornado's.
What is it doing?
But there's nothing on land that's showing a wind blowing around. The sand's not moving.
Okay.
Next.
We'll be at the stadium in 20 minutes.
Okay, so can either of you explain to me why there are exploding stones falling from the sky?
He's the scientist.
I'm a science teacher now, not a scientist. What I think is happening is that volcanic eruption in the coast. It created an atmospheric imbalance, right?
Right.
And the ozone was knocked up into the mesosphere. Then it turned into a liquid and got encased in frozen CO2.
Dry ice. That's why it burned.
Exactly. The primary effect is the water spouts and tornadoes, but the secondary effect is this supercell storm starts funneling down these frozen ozone droplets, turning them to something like
Rocks.
Exactly.
Okay, well, why are they exploding?
Atmospheric pressure. Once they hit sea level, they become unstable and quite volatile. That about right?
That's it.
I don't think any of that is right. If they form frozen droplets, then there's no way for them to coalesce unless they get down into a warmer part. But even then, it's got a very short amount of time. It just doesn't.
To quote Luke Skywalker, it's funny. Everything they said was wrong. It's just painful at this point. You can't knock the ozone layer into the mesosphere. And if you did, it definitely would not freeze and then start hailing to Earth as these huge rocks, but only once they get sucked into a mesocyclone, because these rocks don't fall unless there's a water spout or tornado.
2 years later.
2 years What?
They're really stretching on this one.
I don't even know what they Googled to come up with this concept.
They said words.
There's another gym quote of 2022. Let's keep going.
I think we have a problem here.
Mission Hill and Roxbury have had
think
extensive
you had
damage.
problems at the beginning of the movie.
has finally deteriorated.
What about the tornado in South Boston?
There's reports it just hit the stadium.
Radar image. Upstate New York is getting hammered by a supercell, and then over the ocean is something. I think
Whatever that is,
clear.
it's north of Boston.
Wait, it's a clear sunny day in Boston, according to this.
There's some sort of like residual stuff, but not the core. The core looks like it's north of Boston at that point on that image, but
Hang on, I can fix this. Now, the tornado is hit. We're lying in the rubble, and we're coming up with a plan as to how to fix it.
You can only study the weather. You can't control it.
Dad, you're the storm expert. If anybody can stop this,
I thought he was the volcanologist.
She's right, Joe. And back in the day, you had a whole lot of theories about climate manipulation. Maybe there's a way we can fix this.
I'm a science teacher now, not a scientist. I suppose we could raise the local temperature.
Which would induce global warming on a smaller scale.
That would bring the ozone layer back to its normal level.
Which could choke out the tornadoes.
How is that even possible?
It isn't.
Warm air rise. Warm air push air higher. If
Ozone go higher.
ozone already too high, warmer air make ozone higher, not lower.
It isn't. It would take a level of geoengineering which is purely theoretical. Unless we could find enough firepower.
And how do you propose we do that?
Okay, so the stones are going up.
It's going clockwise.
Clockwise direction.
Ready?
There's the bomb there.
Okay.
They're gonna jump out of a moving car. The tornado is blocks away. Be careful of the frozen ozone.
The wind isn't that strong. So, would something of that magnitude disrupt the flow? Potentially. Maybe short term, because the overall flow of the air is just gonna, once all that energy dissipates, it's just gonna go back to what it was. Not accurate.
Not accurate.
Just put it out there, not accurate.
So we'll just go with, you know, what do we rate it on a meteorology accuracy scale? I would put it at a -1. They don't have much going for them. Entertainment-wise, I mean, I laughed harder at this movie than I think I have at any movie in recent history. Besides maybe 500-mile-per-hour storm. That was...
It was a low bar.
What do you think for meteorological accuracy?
I'm gonna go with 0.5.
Generous.
I mean, they did say, you know, looking at lower barometric pressure.
Yes, but the volcanologist said it!
I know. Well, he's obviously got more meteorological experience than the meteorologist in this movie. Entertainment value, I would say the acting was good. You know, I thought they did a good job with the acting. I thought they portrayed, especially when 99% of it was CGI, them trying to portray something that really wasn't there, like a waterspout or a tornado over water, and they were looking that direction. They did a pretty good job acting.
Sure.
So, entertainment value, I'd probably throw it in the 6.5 range. You know,
it was pretty close.
Wasn't too bad.
Yeah.
But definitely has much room for improvement.
It has.
In terms of the accuracy.
We would have some notes. Hollywood, hit us up.
The trajectory appears to be coming from the northwest over the ocean.
So there you have it. Stonados.
Stonados.
Again, if you like what you saw, this part of it, not that part of it, give this video a thumbs up. And again, subscribe down below. Follow us over on our social media, Instagram and Facebook, as well as checking out our website and again, the School of Weather, which will be linked down below. Until next time, I'm Kayla.
And I'm Jim.
Thanks for watching.
And we'll see you at the next Meteorology Monday.
You do the weather! You know, if you were any good at your job, you would have predicted this!
Editing me is going to pop up a corrector image and put a hat on this guy.